Most world maps hanging in classrooms today are actually out of date. We grew up memorizing 4 oceans: the Pacific, Atlantic, Indian, and Arctic. But in the year 2000, cartographers officially recognized a 5th. While other oceans are defined by the continents that surround them, the Southern Ocean has no northern landmass to hold it in. Instead, it is bounded by an invisible border drawn at the 60th parallel south, forming a massive ring around Antarctica. This 60-degree mark traces the exact path of the Antarctic circumpolar current. It is a ferocious river of water flowing west to east, completely unhindered by land as it loops continuously around the bottom of the globe. The sheer physical force of this current is difficult to comprehend. It pushes approximately 130 million cubic meters of water every single second. Take every flowing river on Earth, combine their water volumes, and multiply that by 100. That is the scale of the flow rushing around Antarctica right now. Because it moves with such intense velocity, the current operates like a thermodynamic wall. It traps the freezing Antarctic waters inside its ring, while physically repelling the warmer tropical currents trying to push their way south. The Southern Ocean operates as an active physical shield. It is a planetary engine that maintains the deep freeze of the ice cap, which in turn anchors the climate stability of the entire world. 30 million years ago, Antarctica was a green, temperate continent. It was securely attached to South America and Australia as part of a massive landmass called Gondwana. Tectonic plates fractured the supercontinent. South America pulled away from Antarctica, opening the 800-kilometer Drake Passage. For the first time, ocean water flowed unobstructed, rushing through the gap and connecting end to end, firing up the Antarctic circumpolar current. Blocked from receiving warm equatorial currents, the continent underwent a rapid flash freeze. The lush vegetation died off, replaced by a solid ice sheet miles thick. The Southern Ocean is the physical architect of this isolation, the engine that froze the bottom of the world. When that immense volume of water is squeezed through the narrow Drake Passage, it creates the deadliest marine environment on Earth. With no land masses to block the wind, the ocean regularly throws up walls of water 15 to 20 meters high. Early sailors navigating these latitudes named them the Roaring Forties and Furious 50s. The absolute lack of shelter turned this stretch of water into a vast graveyard for hundreds of early sailing vessels. Despite the danger, the early 20th century saw the heroic age of exploration, peaking with a brutal 1911 race to the South Pole. Norway's Roald Amundsen utilized sled dogs to reach the pole and return safely, but Britain's Robert Falcon Scott and his team arrived a month later, only to find they had been beaten. On the brutal return journey, Scott and his 4 companions died from starvation and negative 40-degree temperatures. In 1914, Ernest Shackleton attempted to cross the continent, but his ship, the Endurance, became locked in the freezing waters. Over the course of months, the pressure of the shifting ice buckled the hull and crushed the vessel entirely. Stranded with 27 men, Shackleton took a small lifeboat across 1,300 kilometers of violent waves to find help. Miraculously, every single member of his crew survived. Human history here proves a singular point. The Southern Ocean is a fortress designed by nature to repel human intrusion. Beneath that violent surface, the ocean transforms. In the South Sandwich Trench, 8,200 meters below the waves, the pressure would crush a human body in seconds. Yet in total darkness, specialized life thrives. The foundation of this ecosystem is Antarctic krill. These small crustaceans swarm in numbers so immense that they constitute the largest biomass of any species on the planet. These massive swarms sustain almost every predator in the region. This reliable food supply allows iconic species like emperor penguins to survive the most extreme breeding conditions on Earth. Krill also operate as a biological pump. They consume carbon near the surface, and when they excrete waste, that carbon drops into the deep trenches, permanently locking it away from the atmosphere. This tiny crustacean provides an industrial-scale carbon disposal system that is directly tied to the stability of Earth's atmosphere. The Southern Ocean single-handedly absorbs roughly 40% of human carbon emissions and a vast majority of excess planetary heat. It is Earth's primary thermostat. That thermostat is now breaking down. As the ocean absorbs too much heat, the current is shifting south, allowing warm water to undercut the critical Thwaites Glacier. If the Thwaites Glacier collapses, it will trigger a 65-centimeter sea level rise and permanently disrupt vital weather patterns, including the Indian monsoon. Our current need for this ocean stands in stark contrast to our destructive past. During the 20th century, commercial whaling stations hunted species to the brink of extinction out of pure greed, nearly wiping out the blue whale. We are now seeing a slow, fragile recovery of these species since the whaling ban took effect. It serves as proof that international intervention can save these marine ecosystems. With the Antarctic Treaty opening for review in 2048, scientists are frantically mapping the ice and ocean data. They are preparing for an unprecedented geopolitical battle over the resources buried beneath these waters. This desolate stretch of water at the bottom of our maps regulates the air we breathe and the rain that falls on our crops. Our future depends entirely on whether we choose to protect it.